All right, let's just jump right into it. This is a question that sounds like it's straight out of a sci-fi blockbuster, but the science behind it is very, very real. We're going to break down what would actually happen if one of the universe's most violent events took place right in our cosmic backyard. So let's just put the question out there. What would happen if a nearby star went supernova? Now, lucky for us, our own sun isn't massive enough to do this, so we can all breathe a sigh of relief there. But plenty of other stars out there are. And if one of them decided to go, the consequences would be, well, almost impossible to wrap your head around. To even begin to get a sense of the scale we're talking about, you have to hear this quote. Just try to picture it. A hydrogen bomb, one of the most powerful things humanity can create, detonating right in front of your face, and a supernova would still be 1 billion times brighter. That's the level of pure energy we are dealing with here. It's just staggering. Supernovae are the biggest explosions in the entire universe. Full stop. When one of these things goes off, it can literally outshine its entire home galaxy, all hundreds of billions of other stars combined. They're so incredibly bright, in fact, that for centuries, we completely misunderstood what we were even looking at. Take the famous astronomer Johannes Kepler. Back in 1604, he spotted what he called a new star. It was so bright you could see it during the day, and it actually cast shadows on the ground at night. He was so sure he wrote a whole book about it called De Stella Nova, which means about a new star. The great cosmic irony, of course, is that he wasn't watching a birth. He was watching a spectacular, unbelievably violent death. So how does a star even get to this explosive point? Well, for most of its life, we're talking billions of years. A star is a surprisingly stable thing. It's all thanks to this perfect, delicate balancing act between two immense and opposing forces locked in a constant struggle. On one side, you've got the relentless, crushing force of gravity, always trying to collapse the star in on itself. And pushing back against it is the incredible outward pressure created by the nuclear fusion happening in its core. It's this amazing self-regulating system. If gravity squeezes a little too hard, the core heats up, fusion gets more intense, and it pushes back even harder. For billions of years, it's a perfect stalemate. But that balance can't last forever, because a star's fuel isn't infinite. And what's just wild is how fast things unravel at the end. A massive star might spend millions of years fusing plain old hydrogen, but when it runs out and switches to helium, that only lasts for about 1 million years. Carbon fusion? Just 1,000 years. By the time it gets down to fusing silicon, it has just a few months left. The star is tearing through its final reserves at a truly frantic pace. And this is where it all grinds to a halt. Iron. You can think of iron as the ultimate nuclear ash. See, for every element that came before it, smashing them together in fusion released energy. That's the very energy that was holding the star up. But iron is different. Fusing iron into something heavier actually costs energy. So the moment the star's core turns to iron, the furnace at its center just switches off. With that engine turned off, there's nothing left to fight gravity. Absolutely nothing. And a star that had been stable for millions of years is about to undergo a complete and total collapse in less than a second. There's a very specific point of no return for this, a critical threshold called the Chandrasekhar limit. The second that dead iron core in the middle of the star grows to about 1.4 times the mass of our own sun, gravity's victory becomes absolute. It's game over. And here's what happens in that final fraction of a second. Gravity becomes so insane that it literally forces electrons to smash into the protons inside the iron atoms, turning them all into neutrons. As this happens, the now unsupported core just free falls, collapsing at a staggering 25% of the speed of light. All the outer layers of the star, which are now in total freefall themselves, come crashing down, slam into this new, unbelievably dense core, and rebound in a massive shockwave. I mean, just look at this compression. An iron core that was thousands of kilometers wide, bigger than our moon, gets crushed down into a ball of pure neutrons just 30 kilometers across. That is like taking a planet and squishing it down to the size of a city. The density is absolutely mind-boggling. Now, you would think that this colossal rebound, this bounce, is the explosion. But here's the twist. It's not. The initial shockwave actually runs out of steam and stalls. The real power behind the supernova, the thing that actually rips the star apart, comes from a much, much smaller and very unlikely hero. And that hero is the neutrino. These particles are basically ghosts.
They have almost no mass, and they barely interact with normal matter at all. In fact, trillions of them from our sun are streaming through your body right this very second, and you don't feel a thing. To have even a 50-50 chance of stopping a single neutrino, you'd need a block of solid lead that's a light year thick.
So how in the world can these little ghosts possibly power the universe's biggest explosion? Well, the answer is just sheer, overwhelming numbers. The core collapse doesn't just create a few neutrinos. It creates an amount that's almost impossible to say, let alone imagine. 10 to the power of 58 of them.
And here is the secret. That collapsed core is so ridiculously dense, we're talking trillions of times denser than lead, that for a brief moment, it actually manages to trap a tiny fraction of that insane flood of neutrinos. And all that trapped energy is the missing ingredient. It's what reignites that stalled shockwave and gives it the cataclysmic punch it needs to blow the rest of the star to smithereens.
Okay, so now that we've seen exactly how a star explodes, let's circle back to our original question. What if this happened near us? What would the real, tangible effects be for us here on Earth? Well, the biggest danger isn't necessarily the bright flash of light, unless it's super close. The real, more insidious threat comes from high-energy cosmic rays. Think of them as atomic shrapnel, flying at nearly the speed of light. These particles would slam into our upper atmosphere and tear apart nitrogen molecules. Those broken molecules then start a chemical reaction that just annihilates our planet's protective ozone layer, leaving the surface totally exposed to deadly radiation from space. And here's the thing, this isn't just a hypothetical scenario. We have proof that this has happened before. Scientists digging deep in the Pacific Ocean floor found a layer of sediment containing iron-60, a special radioactive isotope that is only made in supernova. Any iron-60 from when the Earth formed would be long gone, so its presence in a layer from 2.6 million years ago is a smoking gun. It's direct evidence of a nearby supernova, and it just so happens to line up with a major extinction event for large marine animals. But for all this talk of destruction and extinction, the story has one more profound twist. Because as violent and as deadly as supernovae are, they are also, in a strange paradox, the great creators of the cosmos. This really sums up the whole paradox perfectly. On one hand, destruction, mass extinctions, bathing planets in lethal radiation. But on the other hand, creation. The insane conditions inside that explosion are the only places in the universe where elements heavier than iron can be forged. What's more, many scientists believe the shockwave from some long-dead supernova is what gave a nearby cloud of gas the nudge it needed to collapse and form our own sun and our entire solar system. And this is where it gets really personal. That calcium that makes up your bones, the iron in your blood, the gold in a piece of jewelry, every single atom of those elements, and every other element heavier than iron that makes our world possible, was created in the heart of one of these cataclysmic explosions billions of years ago. We are, quite literally, made of stardust. And that leaves us with this one final fascinating thought. Are we, in a very real sense, the children of cosmic violence? We owe our entire existence to one of the most destructive events the universe can produce. It's a powerful reminder that out there in the cosmos, creation and destruction aren't really opposites. They're just two sides of the very same cosmic coin.